Please introduce yourself.
Hi, I'm Olivier Bert. I'm the Chief Technology Officer here at Fairphone.
Cool. And here's the Fairphone, great product. But what difficulties did you encounter during the design phase when you're developing the phone?
Well, basically, you're dealing with all the same trade-offs and complexity as designing a normal phone. So the product should not be different in any way to the consumer as an end user. However, you have to deal with the additional complexity of making it accessible and modular and easy to open and repair. And this, coupled with the fact that we are using supply chains that are not designed for long-term supply, that makes it very challenging indeed, right? So you have to think about the fact that the consumer will be able to open the device and play with it and hopefully fix it. And this is contrary to all modern smartphone design, which are usually sealed and completely enclosed for different reasons, right? So you want the product to be as thin as possible, as small as possible, and packed with functions, right? What we're trying to do is actually reopen it, right? Reopen the way the product is architected and designed so that we can achieve roughly the same things without compromising too much, right? Everywhere where we actually start adding modularity, it means that we're adding mechanical thickness or dimensions inside the product. We're adding more components, so connectors, for example, which are different than the connectors we would normally be using, right? So this leads to additional layers of complexities. And the engineers that are basically developing the product with us are not used to think like that, right? It really is a mindset change because they're there to cut cost, maximize efficiency in terms of space and so on. And we're trying to do something a bit different, a bit more challenging, a bit more it's different.
Yeah. It's not design as usual. However, I mean, there are some engineering sectors. I used to work in aerospace, for instance, where design for disassembly, not ease of disassembly, I should add, they were often very complicated things to take apart, but everything could come apart. But in this sector, in the mobile phone sector, as you say, having it taken apart by the user is just a totally different approach, isn't it? Because other companies do not do that.
Totally unheard of, right? So nobody actually wants to do it, basically, right? And understandably, I mean, they are nervous. The companies that we work with to develop this, they are actually nervous about the fact that the consumer will be able to open it. Right?
Yeah, and there it is. And it works.
It works. It works. There you go. On cue.
Fantastic. Yeah, that's interesting to hear that suppliers were nervous about that. They're just not used to having.
They're not used to that, and also builds in because we hold the manufacturer responsible for a certain level of quality and also performance in the field, right? And that the fact that users can actually service themselves, that opens up a lot of uncertainty because they have never experienced this with this type of product. So they're very nervous about it. And so once you get past the stage of them being resisting about it, and they start thinking about how do we solve it? How do we make it possible for the user to actually be able to service it easily in the field? Then the mindset operates, and you get to practical solutions.
Yeah, I can see that. Yeah, and in terms of some of the engineering, the sort of machine elements, how things, mechanisms, and connections, I guess that was quite innovative stuff. You had to design from the beginning, or did you draw lessons from other sectors and other tech products? Or?
We brought in some lessons learned from different types of products, right? We didn't reinvent the wheel on everything. A lot of what we've done has been used in some shape or form in other types of products. But it was really the first time that we actually used all of this into a mobile phone.
What I find interesting is, and I can remember there was a discussion around, for instance, just replacing the battery in competitor products. We won't name any. But there was an argument there of technically this can't be done. You've really turned that around. It's not just replacing the battery, it's taken the whole thing to pieces, as we've seen already. And I think that's very important for sectors to look at this, all sectors that are looking at improving and developing product and redesigning product for repair, refurbishment, remanufacturing, and recycling. if this can be done, anything can be done.
Yes.
Would you agree?
I would agree, but you also have to remember that the economics need to make sense, right?
Yeah.
It's one thing to design the product, but you also need to make sure that you design all the systems around it to be able to support the product in the field. Otherwise, the economics might not make it, right? So yes, it's more expensive to design, to develop, and to manufacture, but you also have to build in the fact that yes, you can keep it alive for longer, and you have to make sure that you enable the customers to be able to do that as well, right? So everything needs to be taken into account when you're designing the product.
Yeah, that's fantastic. When you are developing, you need to test. Obviously, you've got a product going out in the field. You have to make sure it's correct in every way. So how do you do that testing, and is there anything different that you do?
Well, it's interesting because on this particular one, what we did was basically reuse traditional testing methodologies, right? There's a whole testing regimen that you need to survive to establish basically, or to qualify that the product will survive in the field, right? So a lot of tests that are basically there to replicate actual usage and abuse in the real world. So we've done exactly that. What we had to do on top is basically cover the cases which are different in this particular product. For example, opening up the product, we need to be able to qualify that the product will survive if it gets open a certain number of cycles, and that the performance will not be affected over time. So we did have to add another set of tests to make sure that we were not affecting the long-term performance by just playing with it. Yeah. The other thing we did is we tried to look at the durability of the product from the beginning. And we basically made a lot of the tests that were used more stringent than what you see normally in the industry, right? So the traditional modern smartphone, which is basically a glass pane with a rectangle and some buttons around, is normally designed to survive a drop test of about a meter, 80 centimeters to a meter. That's the normal spec we see nowadays. What we tried to do with this one is make it a lot more robust. So we integrated the protection into the phone itself. But to make sure that this actually worked, we increased the height of the drop for the testing. So we increased it to 1.2 meters for quite some cycles, and at the end we were at 1.85 meters. Wow. Right, which is basically standing height. Exactly, standing height, dropping the phone a certain number of cycles to replicate the fact that the phone will get some abuse in the field.
So that's an interesting position, that products designed for disassembly by user can be more robust. Yes. It's not that they're more fragile and more delicate, and it doesn't have to be like that.
No, it can be actually the opposite. In this particular case, the opposite happened, because what we did was getting more structural elements inside of the product to get every module basically its own structure. And at the end, the whole product was more robust and more resilient. Right? Same with the connectors. We use pogo pin connectors between the modules, and those are spring-loaded connectors, and they're very, very resilient. So if you drop it or you just remove it, it just works and it will come back into position.
Wow, it's incredible. So connections and parts need to last over a much longer life. Is there something that you do special, or how do you approach that? Because again, that's totally different, because the guys that make the other competitor products, they don't have this very potentially long life that they're having to think about. You do.
Yes.
Is there anything that you do to?
Well, for example, the connector systems that we've used for this particular one, which are the ones that will be played with a few times at least, they are basically user-friendly. You cannot basically mess them up by playing with them or touching them or anything like that. That was designed for it. If you look at the rest of the connectors that we have inside the product, which are not user-serviceable, they are totally standard board-to-board connectors with anywhere between 30 to 100 insertion cycles, which is not a lot, right? If we were to use those connectors in a product where you would actually be replacing that, you would also have to take into account the fact that you need to be easily able to replace those connectors as well, because the number of cycles is limited, right? Versus the pogo pin connectors, which are rated for a ridiculously large number of insertion cycles.